Okay, so here are my solutions for the homework for the 16th of March. The first three questions are Mechanics 1 questions, starting off with this constant acceleration formula. So we've got a car moving with a constant acceleration along a straight horizontal road. It passes the point O with a speed of 12 meters per second, and then passes point A 4 seconds later. So if I do a little diagram, that's point O. At that point, it's traveling with speed 12, so U would be 12, and T would be 0. And then 4 seconds later, it passes a point A with a speed of 32, so that would be V being 32, and T equals 4, and we want to find the acceleration. So we would use V equals U plus AT, so I'm going to say that to flag that up to the examiner. 32 equals 12 plus 4A. So 32 take away 12 over 4 equals A. So A equals 5 meters per second. 20 over 4 equals 5. And because they're giving you that answer, you've got to make sure that you are giving enough information there to convince the examiner that you're not making it up. So that would sort that out for you. And then B, determine the distance OA. Well, you have a choice here of what you can use, because you know pretty much all the variables now. So if we went for S equals UT plus a half AT squared, S would be 12 times 4 plus a half times 5 times, excuse me, 4 squared. 12 fours are 48. 4 squared is 16. Half of 16 is 8. 5 eighths are 40. So that will be a distance of 88 meters. Then part C, the point M is the midpoint of OA. So the point M would be, say, there. So that distance now would be 44. So we've got S is 44. And what this question wants us to do is to calculate the speed. So it's a new V. The U will be the same. The A will be the same. But we don't know V. So for that selection of variables, we would use V squared equals U squared plus 2AS. So V squared would be 12 squared plus 2 times 5 times 44. So that's going to be 144 plus 440. So 144 plus 440 is 584. So V is going to be the positive square root of that. And they want that to, so that's going to be 24.2 meters per second. Okay, so that's the first question. As far as the mark scheme is concerned, you would get 1 mark for correctly selecting the right equation, 1 mark for correctly substituting into it, and 1 mark for getting the answer right. And that would be the same for this one. 1 mark for selecting an appropriate equation, 1 mark for correct substitution, 1 mark for correct answer, and the same for the final part as well, giving you a total mark out of 9 for that question. Okay, so the next question is a velocity time graph question. So we've got a train travelling along a straight horizontal track, steady speed of 18 meters per second as it passes the point A. So let's set up an axis. Doesn't have to be an accurate, it's a sketch, but a sketch still means that you have to draw it, you know, sensibly with a ruler. So our velocity is the vertical axis, our time is the horizontal axis, and we are starting off a steady speed of 18 meters per second as it passes the point A. So if we have the point A there at time t equals 0, 15 seconds later it begins to slow at a uniform rate. So initially it's traveling at a constant speed for 15 seconds. So for the first 15 seconds it's going to be constant. Then it begins to slow down at a uniform rate for 30 seconds until it reaches a speed of 10. So it's going to drop from 18 down to 10 over a period of 30 seconds. So that would take us to 45 seconds. So that period is an additional 30. And that's a uniform deceleration. So that would be a straight line like that. The train then increases its speed uniformly for 45 seconds until it reaches a speed of 20. So this is going to take it to 90 and 20. So it's going to do that, and again show those transition points as it passes the point B. So that would be the point B. So draw a sketch of the velocity time graph of the motion between A and B. So that's what we've got. So those aren't equal spaces, but it doesn't matter. All they're interested in is the clear transition points, changes in velocity over time. Calculate the acceleration of the train just before it reaches B. So the acceleration, you get that on a velocity time graph by calculating the gradient. So the gradient of this part of the journey, this part of it has got a length or a distance of 45. This distance is from 10 to 20. So the acceleration is 10 over 45, which is 2/9 meters per second squared. And then the distance from A to B, distance on a velocity time graph is the area beneath the graph. So you've got three distinct sections there. You've got a rectangle and then a pair of trapezia. So this section is going to be 18 times 15. This section is going to be area of the sum of the parallel sides. So that side is 18 plus this side, which is 10, times the distance between them, which is 30. And then for this trapezia here, half sum of the parallel sides will be 10 plus 20 times the distance between them, which is 45. So when we work those out, so 18 times 15 is 270 plus, so 28 times 0.5 times 30, 420 plus 30 times 0.5 times 45, 675. Add them together, 1,365 meters has been travelled. Okay, so the marks for that question. There's 1 mark for the method of correctly laying out your graph, and then there are 3 marks for the appropriate sections of information. So make sure that that section is right, that section is right, and that section is right. For this one, there's a method mark for finding the gradient and for getting the correct answer. For this one, there is 1 mark for the method of finding the area, 1 mark for correctly sharing the information, 1 mark for correctly evaluating each part, and 1 mark for the answer 1365, giving a total of 3, 4, 5, 6, 7, 8, 9, 10 for that question. Okay, and then the final mechanics question is again constant acceleration, but this time in the vertical plane. So we've got a particle projected vertically upwards with an initial speed of 15 meters per second. So something is being upwards, u equals 15. Now the way that I always teach this so that you get your signs correctly is to use an arrow convention. So because that is being projected upwards, I'm going to have an up arrow next to it from a point A. It's 1.25 above the horizontal ground. So this distance here is 1.2 with the arrow pointing in the opposite direction. It's s equals 1.2 arrow downwards. We also know its acceleration is 9.8, and that also pulls in a downward direction. And we want to find the time it takes to reach the ground. So u is 15 up, s is 1.2 down, a is 9.8 down, and t is what we want to work out. Now the rule with the arrows is that you can't plug them into the formulae until all the arrows are pointing in the same direction. And if you want to change the direction of an arrow, that it changes the sign of its value. So because I got 2 downwards, I'm going to change that to minus 15 up. And then when I plug into the formulae, all the arrows, minus 15 down. All the arrows are now pointing in the same direction, so I know my signs are going to be right. So I'm going to use s equals ut plus a half at squared. Put in what I've got, so I've got 1.2 equals minus 15t plus a half times 9.8 t squared. So this is going to form a quadratic equation, which would be 4.9 t squared minus 15t minus 1.2 equals 0. And that's the quadratic equation that you've got to solve. T equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay, so t equals 15 plus or minus, so if we work out what's underneath this square root sign now, we've got the square root of 15 squared, which is 225, minus times a minus is a plus, 4 times 4.9 times 1.2, which is 23.52, all over 9.8. So that's going to be 15 plus or minus 23.52 plus 225, square root that. So it's going to be plus or minus 15.76 all over 9.8. Now time can't be negative, so it must be plus. So we're going to add 15 to that, divide by 9.8, and get an answer of 3.1 seconds. So that's the time taken for the particle to reach the ground. And then B is an explain question. Suppose a heavier particle is projected vertically upwards from the same point with the same initial speed. Would the time taken for the particle to reach the ground be greater, the same, or less? Give a reason for your answer. Well, all our calculations there, weight doesn't play a part at all. It's entirely independent of weight, and that's all you need to say. So the time would be the same. As these calculations are independent of weight. So something along, in your words, along those lines could get you those marks. Okay, so mark scheme. 1 mark for selecting the correct equation, suitable equation. 1 mark for correctly substituting into that equation. 1 mark for setting about a solution to the quadratic equation correctly, and 1 mark for your answer, and then 1 mark for a satisfactory explanation. 2, 3, 4, 5 marks for that question. Okay, so now we're into the C3 questions, and the first question is a Simpsons Rule question. So question 4. So we want to use Simpsons Rule to estimate the integral of that. Now Simpsons Rule is that if you are integrating a function y with respect to x, then what you've got is a number of strips, and we want to divide that. The more strips you divide it into, the more accurate your solution is going to be. Now this question wants 5 ordinates. Now 5 ordinates are the sides of the trapezia that we create. So if there's 5 ordinates, there are going to be 4 strips. 1, 2, and those should be of equal length. So this point here will be y0, y1, y2, y3, y4, and these are the widths of the strips. Now to work out the width of the strip, that is going to be, for here, h, which is b minus a divided by the number of strips. This then, your formula is h over 3 multiplied by, for us, y0 first plus last plus 4 times the sum of the odd ordinates, so y1 plus y3 plus 2 times the sum of the even ordinates. Well, I've got y0 and y4 in there, so it's only y2 that we need to go. So that is Simpsons rule. So let's apply it now to our integral. So for us, h is going to be 2 minus 1 over 4, which is a quarter. y0 is going to be 1 over 2 plus e to the 0. And that works out to be one over 2 plus e. Can't find the e there, to the 0. So that equals 1/3. And then y1 equals 1 over 2 plus e to the 1, which is 1 over 2 plus e to the 1, which is 0.211941556. Now I have gone wrong here somewhere, in that this is y0, not that. So that's y0. y1 now will be 1 over 2 plus e squared. So fraction button, 1 on top, 2 plus e squared. Which is 0.106506979. y2 will be 2 plus e cubed. So 1 over 2 plus e cubed, which 1 over 2 plus e cubed doesn't seem to be in the list of answers. As you may have worked out, I haven't taught Simpsons Rule in quite some time. y0, y1, y2, y3, no, I've gone wrong here somewhere. I've gone wrong. What have I done wrong? Okay, I'll come back to that one. Okay, something's gone wrong there. Like I said, it's something I haven't taught in a while, so I'll come back to that as an extra clip. Right, next one. Put me more on solid ground. Question 5. Is differentiation. So this is something that needs to be differentiated implicitly, and it's got an embedded product rule in it. So I think the way that you were taught this was to actually separate it out and then recombine it at the end. So if we do that, so if we differentiate x cubed with respect to x, that's straightforward, it's 3x squared. When we differentiate, that's a product. We've got that part there, which is multiplied by y. So there are lots of shortcuts you could use, but because I don't know what shortcuts you know, I'll put the whole thing out there. So if we let u equal 5x to the 4 and v equal y, we have to differentiate both of those with respect to x. So du dx will be 20x cubed, and dv dx, if you're differentiating a different variable with respect, then that would be 1 differentiate with respect to y and then multiplied by dy dx. So you then combine it, and it's 5x to the 4 multiplied by 1 dy dx plus the multiple of that, which would be 20x cubed y. So then we go to differentiate minus 2y cubed. That would be minus 6y squared, and then we have the dy dx because we've got to differentiate with respect to x, and then finally d dx of 7 is 0. So recombining those now, therefore when we differentiate that, we get 3x squared plus 5x to the 4 dy dx plus 20x cubed y minus 6y squared dy dx plus 0 equals 0. We're looking for an expression of dy dx, so I'm now going to keep everything with dy dx on one side and move everything else to the other. So because these two non-dy dx terms are positive, I want to leave them where they are, and I'll ship those to the other side. So I'll get 3x squared plus 20x cubed y equals 6y squared dy dx minus 5x to the 4 dy dx. So I can take the dy dx out as a common factor. I'll write these the other way around now. So dy dx 6y squared minus 5x to the 4 equals 3x squared plus 20x cubed y, and then I can divide. So dy dx will be 3x squared plus 20x cubed y over 6y squared minus 5x to the 4. So as far as mark scheme for that part, so I can go over to another page, there is 1 mark for the 6y dy dx, there is 1 mark for that. There's a lot of work for those marks. And then there's one mark for that being 3x squared and that being 0. And then the fourth mark is for all the work getting you down to that final expression. And then for part B, so we know that x is t cubed take away 5, and y is t to the 4 plus 7t to the 5. We want dy dx, so what we do first of all is differentiate both of these with respect to t. So dy dx is dy dt divided by dx dt. That's what we've got to, that's how we build it. So dx dt is 3t squared, dy dt is 4t cubed minus 35t to the 4, hence dy dx is going to be 4t cubed minus 35t to the 4 divided by dx dt, which is 3t squared. Now you can take a t cubed out of the top of that, or t squared out of that, leaving you 4t minus 35t squared, and a 3t squared on the bottom, which enables you to cancel those t squareds, leaving you 4t minus 35t squared over 3. So that's part 1. For part 2, this is something peculiar to the WJC. This isn't something that I teach in edXL. To get d2y dx squared, you differentiate your dy dx with respect to t, and then you multiply that by dt dx. And what that will do is give you the d2y dx squared. Sorry, that's dx in there. So that has this sort of notional effect of cancelling the dt's and giving you d squared y and dx squared. D times d squared y on top, dx times dx squared on the bottom. So for our expression, that's going to be differentiating that again with respect to t will give me 4 minus 70t over 3, and then by multiplying that by the inverted dx dt will give me 4 minus 70t over 9t squared. Now all the way through that should be a plus. Just noticed 4t plus. So 4 plus 70t over 9t squared for that. And then for part 3, if I just squiggle that off there so I can fit it all on the one side. So for part 3, d2y dx squared when x equals 3. So when x equals 3, I need to get that in terms, I need to know what t is going to equal, because my d2y dx squared is in terms of t. So x is t cubed minus 5. So t cubed minus 5 equals 3. So t cubed is 8, which means t is 2. 2 times 2 times 2 is 8. So therefore, d2y dx squared will be 4 plus 140 over 9 times 4, which is 144 over 36, which is 4. So marks for that one. You get 1 mark for differentiating x with respect to t, 1 mark for differentiating y with respect to t, a method mark for then combining those two derivatives correctly, and an answer mark for the right answer. You then get 1 mark for this part, the 4 plus 70t over 3, a method mark for correctly using that relationship, and an answer mark, and then you get a method mark here for working out what t would be, and 1 for that. So total marks for that question are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13. Question 6. Now again, this is something that I might wobble with, because this is something that doesn't crop up in the EdXL teaching that I do. So on the same diagram, sketch the graphs of y equals ln x and y equals 11 minus 2x. Okay, well that bit's straightforward enough. Ln x is a relationship you should know, certainly from the functions work that we've done as well. Comes in like that and increases like so. So that's y equals ln x, and then 11 minus 2x, that's going to cross the y-axis at 11, and it's got a negative gradient, so it's going to be something that looks like this. So that's y equals 11 minus 2x. And you can see there it's only going to intersect in one place. So there's only one solution, and that solution is what's called a root. So that's part A. Part B, they're giving us the iterative relationship, and they're telling us that it's got a root between 4 and 5. It's giving us our starting point, which is 4.7. So x1 is going to be 11 minus ln of the previous term all over 2. So fraction button, 11 minus ln 4.7 close bracket, and on the bottom 2 equals 4.726218746. Now you need to write these, if we want these correct to 5 decimal places, then you need to be giving this answer at least to 6, but the safest thing to do is just to write down the string that's on your calculator screen. x2 now then will be 11 minus ln of your previous answer, 4.7 2, 6, blah, 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 over 2. And you want to keep using that full string. Now, on your calculator, that answer is your previous answer. So as long as you don't press clear or anything now, that will be the variable ans. So fraction 11 minus ln ans, close bracket, over 2 equals, and then that's your next one. So 4.723437268. That's going to feed into the next. We've got to go to x4. 4.7234 blah 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 all over 2 equals, so again, fraction 11 minus ln ans, close bracket, over 2, 4.723731615 x4 fraction button 11 minus ln ans over 2 4.723700458. Done that, write down the value of x4 correct to 5 decimal places. So x4 equals, so 5 decimal places, 1, 2, 3, 4, 5. The next one across is another 0, so it's 4.72370 to 5 dp. And prove that this value is correct to 5 decimal places. So what we want to do now is to take the next decimal either side of this one. So we're going to do f of 4.7237065 is the next one. 7 1, 2, 3. The next one down from that, sorry, is 695, and the one above it 4.7237005, and show that there's a sign change between the two. So it's going to be ln of that 4.7237695 plus 2 lots of it minus 11. So ln of 4.7237695 plus 2 lots of 4.7237695, take away 11, 1.46, gone wrong there somewhere, 695, 723695, 723695, that's why. Okay, start again. ln 4.723695 plus 2 4.72365 minus 11 equals minus 1.87 times 10 to the minus 5. So that's negative. That's less than 0. Then we put this one in. and that one hopefully now will be greater than 0. ln 4.723705 plus 4.723705, take away 11 equals 3.45 times 10 to the minus 6 is positive, so there's a sign change. Therefore, the root is 4.72370 to 5 decimal places. So that's the system. Now, if you don't want to keep typing that in like that, you can store that value. So if we typed it once, so let's do the top one, 4.723695, shift recall, which is store, and then A, that is stored now in A, and then we could just have written ln alpha A close bracket plus 2 alpha A, take away 11, and there we get the same thing. So again, if you're happy using your memory buttons on your calculator, it does save you some time. Now, the mark scheme for that question, we've got 1 mark for the y equals ln x, 1 mark for the correct sketch of 11 minus 2x, and 1 mark for showing that there's only one root, one place where they intersect, 1 mark for correctly substituting in and working out once, 1 mark for getting down to writing it as 5 decimal places. Then there's a method mark for taking the points either side, an answer mark for showing that 1 is greater than, 1 is less than 0, and 1 mark for your final answer. 1, 2, 3, 4, 5, 6, 7, 8. 8 marks altogether. The final question, question 6, again differentiating. So again, I don't know what shortcuts you have been given, so I won't take any, but obviously if you're happy with them, then you do whatever shortcut you can. So the first one, if we've got y equals 5x squared minus 3x, I would write that in index form as that. Then I would use the chain rule to differentiate it. I would let u be the embedded function, the 5x squared minus 3x. I would differentiate that with respect to x to get 10x minus 3. So now y is u to the half, which is easy to differentiate. Put the u back in once I've finished my differentiation. And the chain rule is dy dx equals dy du times du dx. dy du, that should be. dy du is a half 5x squared minus 3x to the minus a half, and I'm going to multiply that by 10x minus 3. So that's the first one. Second one, y equals sine to the minus 1 of 7x. That's chain rule again. Let u equal 7x, du dx equals 7. So y will be arcsine of u, dy du. This is a standard result. It will be 1 over the square root of 1 minus u squared. Put in back into that. What I let u equal. So that's going to be 1 over the square root of 1 minus 49x squared. Dy dx is dy du times du dx, which in this case will be 7 times that, which will be 7 over 1 minus 49x squared. So that's part 2. And then part 3, y equals e to the 3x ln x. That's a product rule. We've got a function there being multiplied by another function. Let u be e to the 3x, v be ln x. Du dx will be 3 e to the 3x, dv dx will be 1 over x. Now dy dx is u dv dx plus v du dx. So that's the rule that you need to remember. So it's going to be e to the 3x over x, combining those two, plus 3e to the 3x ln x, combining those two. Okay, so let's dish out the marks there so I can flip the page. So for the first one there, there's 2 marks. So the first mark is for dealing with that and then combining it correctly with the differential of the inside. The second one is 1 mark for correctly working with the right things, 1 mark for the final answer, and for the third one, it's 1 mark for correctly working with the product rule, 1 mark for each final term. And then part B, by writing cot as cos over sine, so if I say y is cos x over sine x, then that is going to be a quotient rule. We've got 2 functions being divided. Okay, with the quotient rule, it's u over v, and then it's v du dx minus u dv dx all over v squared. That's what you're looking to use. So let u equal cos x. When you differentiate that, you get minus sine x. V is sine x. When you differentiate that, you get cos x. So by differentiating those, dy dx will be v du dx sine x times minus sine x minus cos x times cos x all over sine squared x. So there you've got minus sine squared x minus cos squared x all over sine squared x. Now you cannot cancel those signs. because that hasn't been split up into factors. You could only cancel if you could take sine squared out as a common factor. You can't, so there's nothing you can do with that. But you can take, if you take the minus out, okay, so in effect pulling out a -1, check that that's the same thing. Minus times that is that, minus times a plus is that. Now sine squared x plus cos squared x is equivalent to 1. That's one of the first trig identities you will have learnt. So that's going to be -1 over sine squared x, and 1 over sine x is cosec x, so therefore dy dx is minus cosec squared x, which is what you were showing, which is what you were asked to prove. So as required. Mark scheme for that. 1 mark for getting that far, 1 mark if you got that far and got it all right, and then 1 mark for a convincing argument down through that maths to get to show that. So 3 marks for that. Total marks for question 5 is 10. So those are the solutions to that homework. I will go back now and get my head around that Simpsons Rule one, because I went wrong there somewhere, and I'll add that as an extra clip.